Hey guys, happy Tuesday. I hope you enjoyed your Monday off. So today we're going to continue on with exponents. We have a couple more little shortcuts to learn about. So we're going to talk about negative exponents, and we're going to take some notes or fill in some of our notes. So let's take a look over here at, a reminder, we do have a quiz on Thursday. So we'll be taking a quiz on Thursday over exponents and what we have learned so far. Don't forget to do your attendance check-in today. And then on the modules page for today, you have one assignment. It's a maze. It's same style maze as the one that we did on Friday that had kind of a review of what we had learned up until that point. So this one just has a negative exponents in this maze. So I think you'll find the maze goes pretty quickly. So just a reminder, these notes that I'm filling out are coming from this file right here at the top of Unit 6 module, the journal notes right here. So you can make a copy of that file. I did not put text boxes on here, and I've had some people email me about that. And I've mentioned that in my videos, right? So your options are, because it's impossible for you to type all of this into these files. If you have a printer at home, print them out. If you do not have a printer at home, just write the problems on paper and then take a picture of your paper and you can insert it into the Google slide. Or if you would like paper copies, send me an email. I will get the paper copies together for you and I will leave them in the front office of the school and you can come pick them up. But you need to send me an email if you would like copies. I don't mind giving you the copies that we're using in class. That's no problem. I can get that packet ready for you for these files right here. But you do need to send me an email and ask for those, okay? So I'm going to bring up my iPad. So this is the notes right here that's in your journal. So we're going to try to discover negative exponents. Now, negative exponents are new for you guys. And it's kind of weird, the rule and the shortcut that kind of goes with them. So let's explore and see what we can figure out. So we're going to complete one of these tables, which we've already completed one of these tables before. So this is not new. So we're trying to figure out what happens when our powers become negative. So notice over here on the side, it's like our powers are counting down. They start at 3 and they end at -3. So it's like, hey, what happens when we start going from positive exponents to negative? So remember how I told y'all before we were talking about when we learned about the zero property, we learned about this pattern, how we're dividing and we can get the answer that way. Well, that pattern has to continue. So let's see what happens. So 4 cubed is 4 times 4 times 4, which is 64. 4 squared is 4 times 4. That's 16. 4 to the first power is just 4. And we said, yep, that's 4. And then we learned that 4 to the 0 or anything to the 0 power equals 1, right? And we figured that out by following this pattern. We said to get from 64 to 16, you have to divide by 4. And then to get from 16 to 4, again, you could divide by 4. And then 4 divided by 4 equals 1. Well, guess what? The pattern has to continue. So 4 to the -1 equals what? Well, I have to take this 1 and divide it by 4. Well, that is 1 divided by 4. Oh, so negative exponents, we seem to be getting a fraction here. Okay, well then, let's think about it then. So 4 to the -2, I have to keep my pattern going. I have to divide by 4 again. So I'm going to end up getting 1 divided by 1/4, divided by 4. Well, what is 1/4 divided by 4? Let's think about that. Let's take a little side trip, I like to call it. I'm going to write, let me find some space. I'm going to write, I don't really have any space to write, do I? I'm going to write over here. So you have to remember how to divide fractions. My screen catch up with me. 1/4 divided by 4. Well, in order to divide fractions, we say keep, change, flip, right? So that's 1/4, change it to times, divided by, and flip it. Now remember, this is the same thing as 4/1 times 1/4. And then you have to do multiplication of fractions now. So the 1 times 1 is 1. 4 times 4 is 16. Oh, so let me erase this right here. So now we know that 1/4 divided by 4 is 1/16. Oh, okay, interesting. So I'm going to erase this and we'll work another one, the next one. So that means 4 to the negative 3. Again, I have to keep my pattern going. I have to divide by 4 again. Well, that should be 1/16 divided by 4. Remember, that's the same thing as 4/1. So then I have to keep, change, flip. That's 1/16 times 1/4, which equals 1 times 1 on the top. 16 times 4 is 64. So this equals 1/64. So are you seeing a pattern here? Look at our numbers. We have 64. 4 cubed is 64. 4 to the negative 3 is 1/64. So think about it this way. If 4 squared is 4 times 4, and 4 to the 1 is 4, and 4 to the 0 equals 1, well, 4 to the negative 1 is 1/14. 4 to the negative 2 is the same thing as saying 1/. I really need more space here. Let me zoom in real quick. Same thing as saying 1/4 times 4, because 4 times 4 is 16. And 4 to the negative 3 is the same thing as saying 1/4 times 4 times 4. So what we are seeing here is that it's like you're taking the negative power and you're moving it to the bottom and making a fraction. Because isn't 1/4 times 4 to 4, isn't that the same thing as 1/4 cubed? It is, isn't it? So let's see if this pattern continues. Now I want you, let me zoom back out a little bit. I want you to fill in the table for the 2's and the 5's. Now the question down here was, what do you notice about 4 squared and 4 to the negative 2? Well, 4 squared is the same thing as 4 times 4, and 4 to the negative 2 is equal to 1/4 times 4. So that's what I'm noticing, because that's what we got. Let me grab a different color here. Let the screen catch up, because that's what we got. 4 squared was 4 times 4, which was 16. And 4 to the negative 2 was the same thing as 1/4 times 4, which was 1/16. So this is, remember how we call this the reciprocal, when you like take a fraction and flip it upside down? It looks like that's what's happening. So I want you to continue this table 2 and the 5's and summarize. And then after you finish that, I want you to pause the video now and finish those. And then I want you to come back. Okay, so hopefully you had some time to work on that and see that that pattern continues. So this is true for negative exponents. So we call this, and if you look down here at the bottom, my screen doesn't show anything, but there's a quote and it says, cross the line and change the sign. So that is what happens with negative powers. You cross the line and you change the sign on the power. So in our discovery, we saw that it was true when we took something like 4 to the negative 2. Let my screen catch up here. It was the same thing as saying 1/4 squared. Well, it happens the other way around too. If you have a negative in the denominator, if you take it across that fraction bar line, this is the line right here that I'm talking about crossing, it changes the sign on the power. It's a strange thing, but it is true in mathematics, and it's something that we just really need to remember. Okay, so let's look at some examples together, and then I think that'll help you complete your maze, your assignment, your practice. So look at this first one, 7 to the negative 3. So remember, the thing is cross the line and change the sign. So if you don't have a line to cross, you better give yourself one. So remember, we can make anything a fraction by putting it over 1. Okay, so 7 to the negative 3 over 1. So I look and I say, well, which piece is negative? Well, it's the 7 that has a negative 3 on it. So that is what needs to cross the line. So what I'm going to do is move the whole piece that has the negative to the denominator. So now this becomes 7 to the positive 3 because I crossed the line and I have to change the sign. Done. Now, what's left up top? Well, there's still a 1 up there. It's almost like you're flipping the whole thing upside down. It's kind of what it looks like. So this 7 to the negative 3, just like we saw with our table over here when we were doing the 4s and such, set 1 over 7 cubed. Well, you can work that out in your calculator. 1 over 7 cubed is going to be, it's going to be a pretty big number. I mean, what? 7 times 7 is 49, right? And then 49 times another 7 equals 343. There's your final answer. So when we have exponent problems, we do not want negative powers in our final answer. So look at number 2. Some of the powers are positive, but some aren't still negative. Well, we don't want negative powers. If we can get rid of our negative powers and get everything simplified down to just one base of each base, and I'll show you what I mean by that in just a minute, then we know our problem is simplified. Okay, so for this one, we have x to the 8th, number 2, and we have y to the negative 3. So the piece that has the negative power is the y. So that's the one I'm going to circle. And then I know I need to cross the line and change the sign. Well, I don't have a line here, so I'm going to make myself a line. I'm going to put it over 1, so now I have it as a fraction. Okay, so this is the same thing as my x to the 8th was positive, so I'm not going to touch it. I'm not going to move it. It stays there. I'm only going to move the piece that has the negative on it. That's y to the negative 3. It's going to cross the line, and I'm changing the sign on my power. That's my final answer right there. Done. That's simplified. I have no negative powers now. Those two things are the same thing. They're equivalent. X to the 8th over y cubed. Okay, let's look at a couple more. So for this one, I want to simplify this one fully. I have 12x to the negative 4 times y divided by 3x cubed times y. So which piece is negative? Well, the x to the negative 4 is what's negative. That's the only piece that needs to move. I don't need to move anything else. So think about right now, the 12 has a power of 1. The y has a power of 1. This 3 on the bottom has a power of 1. The x cubed has a positive power of 3. The y has a power of 1. So everything else has a power of 1. Everything else is positive. So the only thing that I need to move is the x to the negative 4. So I'm going to leave everything else there. 12, my y, I have a 3, an x cubed, and a y. None of that needed to move. It all had a positive power. The x to the negative 4, however, is a negative power. So I'm going to move it to the bottom, and it's crossed the line. So now I am changing its sign. It's now going to be a positive 4. So now this is a problem like we've been working. I can simplify this. I'm going to take the numbers out front, 12 and 3. And if I saw just 12 over 3 in everyday life math here, I would say that's 12 divided by 3, and that is 4. So I've simplified that piece. And then I'm going to look and I say, well, I have a y on top and a y on the bottom. Those two pieces can cancel. Y over y divides out to be 1. So I'm canceling. And then I look and I say, well, I have 3 x's and I have 4 more. Now there's a shortcut for this, but I'm going to do it the long way first. So that's x times x times x. That's x cubed. X to the 4th is x times x times x times x. Well, this is the same thing as 4 over x to what power? 1, 2, 3, 4, 5, 6, 7. X to the 7th. So if you didn't remember the shortcut, it was to add up the powers. 3 plus the 4 would have given us the 7. There's your final answer. Let's work one more together. Okay, so look at number 4. 5 times x cubed times y to the negative 3. So which pieces are negative? Well, I'm seeing a negative power right here, and that negative power applies to everything in the parentheses. The 5 is not in the parentheses. But look, I see another piece that has a negative power, x to the negative 2. Okay, so for this one, I have 2 pieces that I need to move, and that's okay. I'm going to leave everything else where it is. The 5 is going to stay. It does not have a negative power. It right now has a power of 1 over here. My 4 on the bottom is not negative, and the y to the 4th does not have a negative power. Okay, so that x squared on the bottom has to move up to the top, so it's going to cross the line and it's going to change its sign. And then this other piece that was on the top with parentheses, and I got to bring those parentheses down, x cubed y to the negative 3. So now we have some rules here, some shortcuts that we could use to help us with this. And then we'll simplify everything. Okay, so I'm not worried about the 5x squared and the 4y to the 4th yet. I want to get rid of this parentheses. Oh, you know what I did? I made a huge mistake, guys. And you might make this mistake too. So I'm glad I made it so I can point it out. But yeah, teachers make mistakes all the time. Do you see what I did with this piece down here? It crossed the line, but I did not change its sign. Oh my gosh. Look, let me fix that. I crossed the line. Now let me change the sign. That's the most important part. Cross the line, change the sign. Now I'm ready to deal with that. See, I made a mistake. But when you cross the line, be sure and change your signs. It can happen. It's an easy mistake to make. So I'm just looking, let me grab a different color. I'm just looking at this piece right here. I want to simplify this piece, and I'm going to write it over here in this space. Okay, so I'm noticing right now inside my parentheses, the x has a power of 3, the y has no power written, so I know it must have a power of 1. So I want to remember that shortcut. When I have parentheses and power on the outside, I can multiply my powers. That's the shortcut. And I like to remember that by myself. I think, well, anytime I see parentheses in math, anyway, they mean multiply. So that's the shortcut for the powers. I can multiply the powers. Okay, so here we go. 3 times this 3 is x. 3 times 3 is 9. And 3 times this 1 is going to be y to the 3. All right, simplified. Whoops, I just erased the wrong thing. Okay, so now we can simplify this even more. So let's think about this. If in everyday life I had 5 out front divided by a 4, I would just say that's the fraction 5 over 4, right? I can't simplify that fraction. So my final answer is going to end up having a fraction in it, and that's okay. It's no problem. Now I'm going to look at what else I have. Well, I see that I have 2 x's and I have 9 multiplied times themselves on the bottom. Well, if I write all these out, and I simplified them, well, I would have 2 x's on top and 9 on the bottom. I could cancel some of those pairs, but I would be left with some. I would be left with 7 because 9 minus 2 is 7, and I have more x's on the bottom, so they would be left in the denominator. And then I also looks like I'm going to have some y's here. Well, I have 4 y's, and then I have 3 y's multiplied times themselves. I'm going to erase how I underlined this 9 right here. Y'all, oh, that was so wrong. I should not have done that. Okay, I was going to erase that, but I erased the whole thing. I don't want y'all to think that's an equal sign. So let's just say I did that. I'm trying to bring out those powers there. It looks like I've written some equal signs there. Those are not equal signs. I was simply underlining those powers when I was subtracting the 9 from the 9 minus 2. Okay, so if I have 4 y's and then I have 3 more y's written out, it's the same thing we did up here. I would have a big long line of y's written out, right? I would have 4 and then 3 more. So that would be y to the 7th. So there's my final answer. You see how I say I know I'm done because I only have 1 base x, 1 base y, and then I have the 5/4. That's how I know I've simplified completely, when I only have 1 base of each. I mentioned that earlier. So for instance, this problem over here, when we were at this point, we weren't done yet because I had base y, I had base y, base x, base x. I can simplify these into only 1 piece of that with that base, okay? So this is all there is to negative powers. The negative powers really are not that difficult. You just need to get rid of them first, then do all those other shortcuts we've already been doing. Once we cross the line and change the sign on our power, we were back to what we were working with last week. Okay, so don't let that confuse you. That's the only step. Cross the line, change the sign on your power, then boom, you're working problems like we've been working all of last week. So try your hand at that maze. The law of exponents maze it's set up just like the maze that you worked on Friday. The negative exponent maze is just like the law of exponent maze that you worked on Friday. And if you have questions, email me and let me know, okay?